Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, let's have a look at this log question, and it's one of the wordy ones. We've gone through all the different rules. Okay, so I suppose, how do you use logs if it's a words question? How long would it take €5,000 to increase in value to €6,000 if invested in a credit union at a yearly compound interest rate of 2%? Okay. Now, it's a little bit, I suppose it depends on the order you do chapters in as part of the Leaving Cert, but you would have more practice of financial maths at some stage, so you'll have remembered the compound interest formula from that you would have touched off in junior cert. Okay, you'll be using it again as Leaving Cert, but the compound interest formula tells you that f, which is the final amount, is equal to p, the principal amount, plus 1 plus I to the power of t. Okay, now a bit hard, especially if you're in fifth year and you're doing logs before financial maths, to know that that was the formula to use. Okay, but rest assured that will get easier because you'll have all the chapters done by the time you sit your Leaving Cert. But it's that word compound interest that brings you to this formula. F is the final amount. P is the principal amount, which is a businessy term for the amount you started with. I is the interest rate in decimal. Now this is all here in the chat of the log tables, page 30. And T is time, okay? So how long? We're solving for T, time, okay? Now, when what you need is a power, so because we need T and that's the power, this means we're going to end up using logs, because logs is the branch of maths that lets you get at powers. Okay, so how do we do that? Well, I'm going to do it a couple of different ways because, again, teachers teach this in different ways. The principle is all the same, okay? But I'm going to do it a few different ways. In the end, I want my money to grow to 6,000 and I'm starting with 5,000. Okay, 1 plus, the interest rate must be in decimal, so 2%, so 2 divided by 100, 0.02 to the power of t. And the question asked how long, so this is what I'm trying to get at. Okay, so I'd like to isolate the side on the right, so this bit on the right. I'd like to isolate basically t, get at t. So the first thing I'm going to do is get rid of the 500 or 5,000 by dividing both sides by 5,000. Okay, because they'll cancel there, and then 6,000 over 5,000 is 1.2. And then 1 plus 0.02 is 1.02 to the power of t. Okay, and I hope that makes sense. So that's just straightforward algebra. Okay, now how do I know when to use logs? Well, you know when to use logs when you've everything simplified. So really you've only one term here on the right, which has the power in it. Okay, and you'll know that from the rules of logs. We had to resolve down every side until we had a single term, and then we could try and get at the power. Okay, so it's from here now. It's from here I'm going to do it a few different ways. Up until here, it's all the same. Okay, so I would use, let me just get the rules of logs. So if you've been following along for the last couple of classes, you'll probably guess the rule I'm going to use, because I tend to use them a lot, okay, which is these ones here. Okay, so I know that if now I take the log of both sides and I match the base number, which is A and log A are going to cancel, and I'll be just left with what's in the power, which is t in my case. Okay, so how does that work? Well, this is method 1. I would get log to the base 1.02 of 1.02 to the power of t. And what I do to one side, I have to do to the other. Okay, and why do I do that? Because log to the base 1.02 of 1.02 is 1. Okay, so I get 1t. Okay, so that leaves me with just t on that side, and that's why I like it. And then I need my calculator, and I need this button here, because it's this button here that allows me to put in any base number, and I need to put in 1.02. Okay, this button here on your calculator is actually log to the base 10. Okay, this button here on your calculator, so there's 3 log buttons on your calculator. This button here, ln, is actually log to the base e. Okay, these two are the most common logs used, and that's why they have their own buttons. But this one here allows me to put in any base number I want. So that's the one I'm going to use. So I'm going to hit that button, and I see the base is flashing. So 1.02 into that. Oh, sorry, I hit the wrong button. 1.02 of 1.2, and I got 9.2 for t for that one. So 9.2 years is the length it's going to take for 5,000 to increase to 6,000 at a rate of 2% compound interest. Okay, method 2, okay? And I say methods, but really it's the same thing. So many teachers teach this with ln, and you take the ln of both sides, okay? So take ln of both sides. So I'm going to go back to 1.2 is equal to 1.02t. Okay, so many teachers default to just use an ln for everything. And I want to show you that is perfectly okay. It doesn't matter. Okay, and the easiest way to do that is with maths. So what have I done here? I've literally just got the ln of both sides. Now, why did I do that is a better question. Okay, well, I want to access this power. Okay, and if I go to the rules of logs, the rule that teacher is using when they take the ln of both sides is this one here. Okay, maybe I'll move those rules down with that way. So what's this one telling us? Well, it's telling us that if I have something in a power, I can take it down in front of the log. Okay, so what does that allow me to do here? Well, it allows me to take this t and take it down in front. So I can write this as t ln of 1.02, and then the left stays the same. Okay, and then I'm just going to divide across by ln of 1.02 because that's just a number. Okay, so divide both sides by ln of 1.02, ln of 1.02, so that they cancel there on the right. So I have t equal to ln of 1.2 over ln of 1.02. Okay, put that into your calculator, hit your fraction button, ln of 1.2, close your bracket, ln of 1.02, close your bracket. And I've got 9.2 again. Okay, as you should. Okay, and of course you can put into your calculator using that same log button where you can put in any base. You can write ln as log to the base e. Okay, and just, I suppose, persuade yourself that they are the same thing. Okay, now I'm going to call this method 3. It's not really method 3 because you'll see we're doing the same thing. Basically, you can take any log you want to both sides. Maths is like that. You can, what you do to one side, you can do anything to an equation basically, as long as you do it to both sides. As long as you do it, apply it to every side of the equation. Okay, so just to prove that, and you can take any log example you want. Let's go back to 1.2 being equal to 1.02 to the power of t. And this time let's take log to the base 10, or just log of 1.2 being equal to log 1.02 to the power of t. Okay, using the same rule, the whole reason we take logs is so we can take that t from being a power down in front. Okay, that's why we do this. That's why we take the logs of both sides. Okay, and then you're going to divide both sides by log to the base 10. And if you put that into the calculator, I haven't it done, but you're going to get 9.2. Okay, so people get confused sometimes in just how do I know when to take the ln of both sides? Okay, how do I know what log to use? So the reason I've done this one 3 different ways is just to show you it doesn't matter. Okay, so in just the same way as I used log to the base 1.02 of both sides, if you want to see it like that, you can use ln of both sides, you can use log to the base 10, so you can do whatever you want. Okay, just as long as you use logs, because logs lets you get at that power. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.